Welcome to this very brief overview of the key concepts covered in our Foundation to 6 MOOC. I will be briefly talking about digital systems, data, algorithms, and visual programming. If you are familiar with all these topics, feel free to close this video and not see my face again. If you feel uncomfortable with these topics after this video, please consider taking our Foundation to 6 MOOC. A digital system is comprised out of computer hardware and the software that runs on it. The raw data that the hardware uses is meaningless to us unless it is represented in a form that we can use, and the operating system of a digital system allows us to run software on top of the hardware to make things happen. Even a simple keystroke on a keyboard doesn't mean anything unless the hardware knows to look for it, then sends the information on which key is pressed to a piece of software that can do something with it. There are many examples of hardware and many examples of software that runs on it, and the following are just a few. Computational thinking involves analyzing a problem, working out what information is needed to solve the problem, this is the data, and then coming up with a sequence of steps that can be used to describe the solution to the problem. This is what we call the algorithm. We'll discuss algorithms very soon. In this example, we have the problem of sorting out a group of blocks by color. The data that we need in this case is the color of the blocks. We can see the sequence of steps, picking up a block, identifying its colors, and then working out which pile of already sorted blocks it belongs to. In digital technologies, data refers to numbers, characters, images, symbols, and sounds that can be manipulated, stored, and communicated by digital systems. On this slide, we present a collage of some types of data representation you might be familiar with in your everyday life, from clocks, banking, and your shoe size to bus timetables. We also have our own data, which includes things like our eye color, our weight, and even our favorite foods, which might be asked of us. This information helps inform us and enables us to make decisions. Data comes in different forms. Essentially, data can be numeric or categorical, also known as quantitative and qualitative data. Continuous data includes data that can be within a measured range. For example, measurements or weather or money or volume. This type of data can include decimal places, and you can also measure it between ranges. Discrete data are things that can only be counted in whole numbers. For example, 3 kittens, 2 cups, or 1 book. You can't really have 2.5 kittens or half a book. The other form of data is categorical data. In the research world, we refer to this as qualitative data. Categorical data can be nominal or ordinal. When being used by computers, all of this data around us is represented in the form of digital text, digital sound, and digital images. Computers transfer text using encoding techniques. Text is encoded and decoded using the ASCII system. To make digital sound, the analog wave is converted into a stream of numbers, and then the numbers are recorded instead of the wave. This process is referred to as analog to digital conversion, or ADC. To play the music back, the computer converts the numbers back into analog waves by digital to analog conversion, and the analog wave comes through the output, such as your speakers or headphones. Unless there is some kind of corruption in the file, it should play the same sound every time. Images are everywhere on computers. Some are obvious, like the photos of web pages and icons on a button. Even a font is a collection of images of characters. Let's look at this image of a frog. We can see the image is clear and of good quality. But what happens when we zoom in on the picture? When examining images, if you zoom in, you'll start to see small blocks begin to appear. The number of small blocks in combination are called the resolution. If we keep zooming, we can see the blocks get larger and larger. A tiny piece of the picture or a colored block is called a picture element, commonly referred to as a pixel. This little pixel describes this little piece of information of the picture. If we had, say, 100 pixels by 100 pixels, this will give us a total resolution of 10,000 pixels.